Today, let us see how to make use of the operators in the programming. So I'm taking some sam.c simple program. So here we need stdio.h and stdio.h mostly because we are going to make use of printf and scanf. Standard input output dot header file. This printf and scanf which are already defined in stdio.h. Okay, that's why we need to include this header file. And the syntax we have to take int main. By default in GCC compiler, the return type must be int. This is the main function. Our execution will be started from here. So here, for example, I want to take some integer variables. The variable declaration must be the first line of the main function. The variable declaration must be here already. Here, for example, I am taking the values. Some a is equal to 10, simple assignment. Comma b is equal to some 20. Some c is equal to some 30. These are the operations I am performing. In the printf, how to make use of them with the help of um, operators, how to perform arithmetic operations and logical operators and bitwise operations, how to perform them. Let me show you. For example, here if you want to perform some arithmetic operations, addition. So how to perform addition? Addition is addition of A and B. Let's assume addition of A and B. I'm taking only two variables. Let's assume separated by comma and ended with semicolon. Addition is equal to, it is a result must be in integer type. The format specifier is percentage %d. If it is float, percentage %f. If it is char, percentage %c. So here it is the result. Within the double quotes, I am giving the escaping character \n. Here I am performing addition. So here it will print the addition of A and B. Actually, here it will perform the arithmetic operation. The result, that is 10 plus 20, 30. Here the addition is equal to 30 will be printed. Okay. So likewise, we can perform uh, so the escape mode. If you press YY, the current line will be copied. If you press P, that will be printed. Here I am taking, for example, subtraction. That will print the subtraction of A and B. Here, multiplication, asterisk. Here, division I am taking, division. Here, modulus. Division means coefficient value will be given. Modulus means a remainder value will be given. Okay. So these are the operations. If you want to perform logical AND operation, we know about the truth table. Logical AND operation also we can take. Actually, this logical and logical or at the time of conditions we will take. At the time of conditions, true statement, false statements. In such cases, we'll take. Let me perform. For example, we know increment and decrement operators. A plus plus, which means A is equal to A plus 1. Here the result will be 11. 10 plus 1 will be printed. Here I am taking some B plus plus. Sorry. B minus minus. So here that value also will be printed. For example, pre-decrement, that is minus minus A. So is equal to A is equal to A minus 1. That is the meaning of this one. Okay. So these are all some increment and decrement operators, and arithmetic operators. So the result which I have taken, that is in integer format. We can take in the integer format. So at last we have to take return 0. So here this first line and this ending line must be fixed in the GCC compiler. Okay. So now I am executing shift colon W, write and save, enter. GCC space sam dot c dot slash a dot out. See, addition of 10 and 20, 30. Actually, we have to take subtraction. This is subtraction value. We need to edit this. Sub is equal to 10 minus 20. How much? Minus 10. Multiplication 10 into 20. How much? 200. Here division means 10 by 20. How much will get? 0 point something. Here we are taking integral value only, percentage d. That's why 0 will be printed. And here it is modulus operation. Modulus operation 10 modulus 2. The remainder will be given. Here in the modulus operation 10 modulus 2. Why it is giving 10 means here dividend and divider we are having. If the dividend is the lesser than the divider, then dividend will be the remainder value. Dividend is the remainder value because dividend is lesser value than the divider. So automatically in the modulus operation, that dividend value will be the result. If it is 10, 20 modulus 10, then what is the remainder? 0. 20 modulus 10. What is the remainder? 10 twos are 20. Remainder is 0. So such case 20 modulus 10, 0 will be given. If 10 modulus 20, so 10 is lesser than 20. That's why 10 will be the result. For example, if we are having 1 modulus 2, so 1 is lesser than 2. That's why the modulus value will be 1. 9 modulus 10. That time the result value will be 9 because 9 is lesser than 30. Next, we have seen the A plus operation, increment and decrement operations. Actually, here we should get 10 because here it is printing a post decrement. Post decrement values, here it is printing. Sorry, A plus plus means A is equal to A plus 1. That's the meaning. But in the printf, automatically the first A value will be printed. That's the problem with the increment and decrement operations. Here addition. Sorry, here we have taken B minus minus. I think we have taken B minus minus. B value it is initially printing without performing the minus operation. Then addition, that last variable we have taken minus minus A. So internally the value is 11. So here after pre-decrement means that will perform the decrement operation, then print the result. Now the value is 10. That's why it is printing 10. We can check here. So there is some headache with this increment and decrement operations. That's why in Python language, they won't allow this increment and decrement operators. Okay. There is no concept of this increment and decrement operators. Next, we are having a few more operations, which are bitwise operations. So here bitwise operations also we can perform. For example, here if you want to perform A A and B. What's the meaning of this? Here this 10 will be converted into binary number. Then on the binary number and 20 also will be converted into binary number. For these two, the AND operation, the bitwise AND operation will be performed. Okay. So like that, so we can perform some A pipeline B. This is logical OR operation. Here also A and B will be converted into binary numbers. Upon that, OR operation will be performed. We have exclusive OR operation. A cap, that is called caret, and B. So here also it is bitwise operation. And here if you want to perform negation, means tilde symbol. Negation A. Negation A means what? Negation A is equal to, there is a some formula. Negation A is equal to minus A plus 1. Or negation N is equal to minus N plus 1. Okay. Here already we are having 10. Minus 11 will be the answer. So this is what about that. Next, we are having one more shift operations, left shift and right shifts. Observe here, A left shift 1. The meaning of this one is left shift means multiplied by 2. So how many times? One time. Multiplied by 2. 10 left shift 1 means one time we will do the left shift. It is also bitwise operator. What is the meaning of this? So this A value will be converted into a binary number. In those bits, all the bits will be shifted to the left. All the bits will be shifted to the left. Okay. So that time the value will be gets incremented. The value will be gets incremented. That's the meaning of that. So here left shift means multiplied by 2. That's the meaning. 10. A 10 left shift 1 means one time we are shifting the bits for the value called 10. Here multiplied by 2 one time. That is the result. 10 into 2. 20 will be the result. If you take, for example, here I am taking B, I am taking B left shift 2, I am taking. What does it mean? We need to perform 2 left shifts. We have to move the bits, means binary numbers. 2 positions we are going to move. 2 times we are going to move. That's the meaning of this. So this time 2 times we need to multiply the 20. So 2 into 20, how much? 40. Again, here 2 means 2 times we need to shift. 2 into 20, 40. 40 into 2. Again, 80. 80 will be the result here. Left shift means multiplied by 2. For example, here right shift I am taking. B right shift 1. Here 1 means one time divide by 2. One time divide by 2. That's the meaning. So here 10 divided by 2. How much we will get? The result will be 5. Here, for example, here I am taking B. B right shift 2. Here 2 times we are going to divide by 2. So for example, B value 20 divided by 2. How much? 10. Here we are having 2. That's why 2 times we have to. 10 we got. 10 by 2 again. We will get 5. So these are the operations will be performed with the logical, bitwise operators we are using. Bitwise operators. Sam.c. GCC dot slash a dot out. See, observe here. 20 right shift 2 we have taken, means 2 times divide by 2. The result will be this. 10 left shift, 10 right shift 1. 1 time divide by 2. 10 by 2. How much? 5. Here we have taken 20 left shift 2. 2 times we have multiplied by 2. 20 into 2, 40. 40 into 2, 80. So remaining operations also like that we have. So these 4 are the and, or, caret, negative. Here negation. Negation A we have taken. Negation 10 is equal to minus 11. That is the answer. So it is about the operators which we are having. Now let us go with taking the values dynamically. Taking the values dynamically. S1.c here I'm taking hash include stdio.h int main. Let us perform some floating point variables operations. Float here I am taking some x comma y comma some z variables I am taking. Here my concept is performing addition of two floating point variables means fractional part also. If you want the fractional part, we have to go with the data type called float. If you don't want the fractional part, you can go with int. So here, just I wanted to perform some operation with float. Here I wanted to take the variables with the help of scanf, which means reading the values at runtime. It is called dynamic uh, reading values. Okay. So dynamically, we are going to read the values at the time of runtime. Means we can modify. We are not taking any fixed values here. So that time, here I am prompting. I am prompting a prompting message. I am taking enter x and y values. For example, enter x and y values which are floating point values. Okay, here I am taking. I am prompting a message. This time I am going to read the values with the help of scanf. So here I am going to read the first value, that is x value, which is of type floating point. Float will be represented with percentage f. Next value also I am going to read, that is y, which is also type f, percentage f, floating point. So double quotes, comma. So ampersand means the first value will be stored in x and the second value will be stored in y. Ampersand means address of variable, address of x and address of y. The values will be stored in the addresses of the x and y. So this is the way of reading the values dynamically. If you want to perform the addition, some z is equal to y x plus y. These two values will be added. The result will be stored in z. Now I am going to print this printf percentile. If you want to take addition of two floating point variables is equal to percentile f. I'm taking some backslash n to print that line in the new line. Percentile f. So here we are going to print the reference for this percentile f. We need to give the reference. So which value we are printing z. So that z here I have to give after the comma. Okay. Finally return 0. This will be accepted. This must be written, otherwise GCC compiler will generate error. So this is the way of reading the values dynamically with the scanf. Compile it. GCC space s1.c printf. Observe here, you will get the errors also. Printf, I wrote wrong here. Printf, open it again. And here, first statement. Okay. GCC space s1.c compiled ./a.out. Enter x and y values. Floating point values I wanted to give 3.5 space 6.4. The result is 3 plus 6 9 9 9.9. So 6 expression points will be printed by default. Okay. So addition will be performed like this. So this is the way of performing the reading the values dynamically. Here, what is this first printf, sir? just guiding. For example, if you wanted to log in into Gmail, so that will prompt you, enter email ID here, enter password here. Likewise, some strings will be shown there. Likewise, it is also a prompting message. So prompting message will be printed. So afterwards, whatever the values we are going to give, which are must be floating point, and that floating point values will be taken. This first value will be taken into X. This order must be clear. Second value will be taken into Y. Those values of type must be float. That's what here we are mentioning. So afterwards, it is performing the addition. So finally, the result will be stored in Z. So I am going to print that result like this with the help of. So reading the values then. So we have seen operators and how to read the values, and in the last class we have seen the data types also. Let me perform one more operation with the character data type. Char. The character will be printed already. Yesterday also we have seen char. Some variable we are taking. Some ch is a variable I am taking. The character values must be represented within the single quotes. For example, here I am taking some s is my character. Okay. So if you want to print that, you can print here at last or somewhere else. Printf backslash and already taken. Value of character or char is equal to percentile C we have to take. Already I am printing, just simply printing percentile C. What's the reference for this percentile C? Which character value I am printing? CH is a variable. So that value I am going to print. Okay. So here, in order to represent that, we are going to take GCC space S1.C. I'm taking some 2.4. You can take in the new line also some 7.7. I have given enter. By default, it has taken. So addition it has performed. Then value of char, that is S I have given, that is printed. It's fine. Okay. So like this, we can perform any operations, and you may have some doubt about data types and all. For example, if you want to take some the value in lakhs, so that time we may get some problems with integer. For example, some int x is equal int a is equal to, here I am going to take some bigger value 9 8 1 2 3 4 5 6. Let me take this bigger value. I am going to print it. Let us see how it will be. I am not printing this, simply I am printing value of a. Value of a is equal to percentile d backslash n. So we can check. So what it will do? GCC space s1 dot virus dot slash a dot out 2 and 3 floating point values selected. Here, what is the value of a which I have given there? That is started with 9, but here it is showing 36778656. 36778656. Observe here, I have given 98213456. It has to print it. It has to be printed as it is, but it is showing a wrong value because with the integer data type we cannot hold the bigger values. So already we have seen some 65,536 some value we have seen, that is based on the data type. If we want to hold the longer data type, longer values, that time it's good to take long int, otherwise long int, long int. Here I may hold this value with long int. will be long int will be represented with percentile LD 98213456. Let us see whether it is printed or not. Some 3 and 4. So even now also it is not holding 693110. So that value is so much bigger. So that's why that is not holding. Let us take long int. Let us take long int. Percentile LLD. Percentile LLD 98213456 should be printed. Let us check. Compile, run it. Some 2 1 and 2. Even now also it is not holding. It's a bigger value unable to hold. Let us try with double, long double. Let us try with long double. Long double will be represented with the double means it's a floating point variable. Long double capital LF we have to take capital LF. Let us see. GCC space s1.c dot slash a dot out 2 and 3. Here it is not holding. So much bigger value. Let us decrease. Well, 1, 2, 3, 4, 5, 6, 7. 9 crores value. 9 crores value it is not holding. Actually, it should be holded with at least a long int or long int. Okay, it's not taking. Maybe the compiler is unable to hold it. It has to be accepted. So what's the meaning of this? What I'm telling you now? It's good to take if you are going with the longer values. It's good to take the data type long int or long int. If you want to take only integral part, in such cases, you need to go like this. That's what I'm telling you. Okay, it is about the data types, and till now we have seen all data types, how to represent them, how to make use of them. We have seen. Now, sir, sometimes we wanted to hold some names also. My name is Jishnu. I wanted to hold my name. In such cases, which data type I have to take? Actually, for that we are having a data type called character data type only, but we'll take the concept of character array concept. For example, name is a name. Array will be represented with the square brackets. So, for example, if you want 20 character space, we have to take the size is 20. So we can take the printf, enter your name, enter your name. Okay. In the scanf, I have to read it. Otherwise, you can take static value also. Scanf percentile s will take if it is character array, set of characters. Then comma, if it is a string variable, sorry, the array, we can call it as character array. For this, we need not to take ampersand because name itself will hold the address. That's why we will not take any ampersand here for string variable only exclusively. Printf backslash n your name. So here will be printed. Percentile s will take in order to print your name, and comma, and the reference is name. That's so this will be printed. We can check it gcc space s1.c dot slash a dot out. Your name, for example, Jishnu. So you enter your name. You have entered your name is Jishnu. It is printed. Okay. So like that, we can hold the variable names also. That is while discussing about the character array, we will talk about all this. Now we cannot understand this character array. Here, instead of this, we can take the direct static value also. Static value will be represented within the double quotes. Jishnu, here if you are taking, we can take in the double quotes also. Okay, simply I am printing your name. Your name. Simply I am printing. This is called a static value, fixed. We need not to give at runtime. Directly it will be printed. GCC space s1.c dot slash a dot out. Your name. Just okay. So like this, we can make use of all the variables and data types and declaration, format specifiers we have seen. Okay. So now it's the time to move to control statements. It's time to move to control statements. The control statements, just I will categorize. Now I will show you what are the categories of control statements. It is very, very important concept. For example, convert some txt file I'm taking. Control statements. What are the control statements? Here, control statements means which are used to control the code. If you want to execute a specific few lines repeatedly, we need the controlling of such 3 lines repeatedly should be executed. So that time you need to control. And if you want to execute a particular few lines with some condition, if that condition is met, then only those 2 lines must be executed. There also we are controlling the code. So likewise, we can control the code such that we can perform whatever the operation just we want. That's why control statements are required. That is, if you want to execute repeatedly, if you want to execute based on the condition, if you want to execute based on the option which we are giving, such cases we need the help of the control statements. We have 2 categories here. One is conditional statements, conditional or selection statements. We can call it as conditional or selection statements. Second one is looping or iterative. Looping or iterative statements. Okay, these are the 2 categories we are having. What are the conditional statements we are having? Simple if and if else. Okay, here nested if else, else if ladder, and switch case. Okay, and switch case. Here switch case will be represented. Space so that it can be switch case we are having. So the looping statements are while loop, do while loop, and for loop. Okay, so these are the looping statements. Just to remember the list of control statements, which are conditional or selection statements, simple if else, nested if else if ladder, switch case. So here we will have the conditions. Based on some conditions, the particular block of code will be executed. Here looping statements. Looping statements means here also we will be having condition. Based on the condition, the particular statements will be repeatedly executed. Number of times will be executed based on our condition. So number of times also we can specify. Okay, that's what we are going to learn in the control statements. Let us go with today simple if and if else. Simple if and if else. Let us see how we are going to perform. That is conditional statements. So let us go with some if dot c. I'm taking. Just I'm taking a comment, taking a multi-line comment slash asterisk. How the if statement we are taking. The syntax, how the syntax will be. So the syntax here will be having if condition. If is a keyword. Within the bracket, we will be having the expression or condition. Expression, or we can call it as condition within the parenthesis. And here we'll be having open brace. After that, here we'll be having statements, number of statements we are going to have. Then close. This is called simple if syntax. If statement syntax. So from here to here. Let us see how we are going to perform. Asterisk slash ending. Observe here multi-line comment will be started with slash asterisk, then asterisk slash. So all this will comes under the comment. So now let us go with the code. Hash include stdio.h int main. Here my operation is whether the given number is even number or not. Whether the given number is even number or not. What's the condition? What's the logic? Even number logic. If a given number is divided by 2, the remainder is 0, that is called an even number. That's the logic. Here I am taking a number into, for example, n is my number. I am taking printf. I am prompting enter n value. I'm prompting enter n value. I'm prompting it. So afterwards, I have to read that n value, that is scanf percentile d, then ampersand n. So the value will be folded in n variable. Let it. Now, if condition I'm using, whether it is even number or not. So for that, if here I'm going to write the condition, if n modulus 2 is equal to 0, then it is called even number. Observe the logic. We need to know these logics to write the code. Okay, for this purpose many algorithm concepts also will be taught. Actually, we need to have this logical thinking. Here n value is even or odd. In order to check that, here I am taking percentile. Percentile means here modulus. Modulus means what? Remainder value will be given. N modulus 2. Here, for example, n value, if I give 10, 10 modulus 2 means the remainder value will be 0. If it is 0, then it is called even number. If this condition is true, this true block will be executed. That is printf. Printf \n. N is an even number. N is an even number. Otherwise, instead of n we can give percentile d is an even number. Percentile d means whatever the value which we have given, we are going to represent with n variable we are taking. Here backslash n is different. That is new line command, new line related concept. This statement will be printed in the new line. After that also the dollar prompt will be printed in the new line. Okay, for that purpose I am taking backslash n. I am giving a reference for this percentile d, that is n. N is the variable here. Then at last I am closing if block. Then return 0. Return 0. So then close it. Observe here, same condition, if condition, whatever we have written here. If that condition we are writing, if this condition is true, then only this block will be gets executed. If this condition is false, that will go to the next part. There is no next part here. I am writing. Here I am not writing anything. That's why nothing will be printed if this condition is false. So let us see. Now, for any number, it has to work. GCC space if dot c dot slash a dot out. Enter n value. For example, I am giving 10. 10 is an even number. 10 modulus 2, the condition I have written there. So the remainder value will be 0. That's why it is called even number. For example, I am running it same. 11 I am giving. It is not printing anything because if the condition is false, there is no block. I didn't write any block if the condition is false. So for the false condition, I didn't write anything. So that's why here I'm taking one more file, VIFX. Okay, observe here. So for false statement, we didn't write anything. That's why we are having the concept called else block. So if it is, that is coupled with the if block. Else, if the condition is false, this else block will hold. Else block will hold the result. Okay. Else block will be gets executed. Now same operation I am performing. If the condition is true, this true block will be executed. Yeah. If the condition is false, that immediately will move to the else block. Else block. Then printf. Here we can write percentile d is an odd number. Yeah. If it is not even number, surely this will be an odd number. The reference is n. Observe here. Close this else block. So this else blocks must be written after the immediate if block. Then only it will identify the else block. So now we can see GCC space if else dot slash a dot out. I am giving some 20. 20 is an even number that is printed. Okay. Here I am taking, for example, some 21. It is an odd number. It has to hold. Now 21 is an odd number. It is printing. So means the control move to else block. Okay. This is the way of using simple if we have seen. If you don't want any else block, we can go with simple if. If you want the else block, we can go with else block. Based on our program, based on our concept, we can mold our code. Okay. If it is for the simple modulus operation. Let me show you one example and wind up the class today. One more example. Here I'm taking, for example, I wanted to check whether given number is positive value or negative value. Whether the given number is positive value or negative value. How can we check whether the given number is positive or negative? If it is greater than 0, that is positive. If it is lesser than 0, that is called negative. Here, for example, I am taking n is greater than 0. N is greater than 0. If it is n is greater than 0, then it is called positive. Here, the true block will be executed. If this condition is true, 10 is greater than 0, condition is true, this true block will be executed. Here we can write whatever we wanted to write. Here if I give minus 10 is greater than 0, condition is false, means failed, that will go to the else block. Here this will be printed. Here if n is greater than 0, here I am writing percentile d is what called a positive number. Percentile d is a positive number. Yeah. Here, if that condition is failed, surely that will be negative number. That's why here what we write, percentile d is a negative number. Yeah. So this is the logic we have to write. GCC space if else is my program dot slash a dot out. Here I am taking first 10. 10 is a positive number. I'm executing it again. Some minus 12 I'm taking. Minus 12 is a negative number. Yeah. So our program is identifying. It is like one application. You have developed one application. Okay. So it is the syntax and execution of the if, simple if, and if else. It's enough for today.